December 18th, 1944. Morning. A roadside ditch 3 kilometers east of Krinkelt, Belgium. Private First Class Richard Brookins crouched in frozen mud, gripping a weapon that most of his battalion still called that damn stovepipe. The M9A1 Bazooka weighed 13.5 pounds and looked like a plumber had assembled it from spare pipe and scrap metal. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Brookins was 22 years old, from a small town in Ohio where he'd worked in his father's hardware store. He'd been in Belgium for 6 days. His unit, 2nd Battalion, 23rd Infantry Regiment, 2nd Infantry Division, had been holding defensive positions in the Ardennes forest when the Germans launched their surprise offensive 2 days earlier. Now they were falling back through the Elsenborn Ridge, trying to establish a new defensive line while German armor pushed west toward the Meuse River. Through the morning fog, Brookins could hear the distinctive metallic grinding of tank tracks on frozen ground. The sound was getting closer. He had been trained on the bazooka for exactly 4 hours during a replacement depot course in England 3 months earlier. The instructor had told them the weapon was effective against medium tanks at ranges under 100 yards. He'd said nothing about what to do when you heard something much larger coming through the fog. The tank emerged from the tree line at 75 yards. Brookins recognized it immediately from recognition cards they'd studied during training. A Tiger II, the German Königsstiege. King Tiger. 68 tons of armor. The frontal hull was 150 millimeters thick. The turret front was 180 millimeters. The recognition cards had been very clear about one thing. American tank destroyers struggled to penetrate King Tiger armor even at close range. Infantry anti-tank weapons were considered essentially useless against it. Brookins had 2 rounds of M6A3 high-explosive anti-tank ammunition. The warhead contained 1.5 pounds of Composition B explosive behind a shaped charge cone designed to focus the blast into a superheated jet of metal that could theoretically penetrate up to 4.5 inches of armor. Theoretically. The math was simple and discouraging. 180 millimeters of German armor equaled just over 7 inches. His warhead could penetrate 4.5 inches. 7 is more than 4.5. But the King Tiger was moving forward, and behind it, Brookins could see German infantry following in the tank's wake. If the tank reached the American positions, it would overrun the foxholes, where most of his company was still digging in. He loaded the first round, extended the wire leads that armed the electrical firing circuit, and pressed his cheek against the primitive sight. Rail. The instruction manual said to aim for the turret ring, the junction where the turret met the hull. Armor was thinnest there, usually less than 100 millimeters. But hitting a moving target the size of a large dinner plate at 75 yards with a weapon that had no rifling and virtually no aerodynamic stability required either extraordinary skill or extraordinary luck. Brookins had neither. He had desperation. He squeezed the firing lever. The rocket motor ignited with a violent blast that sent a backblast of flame and smoke 15 feet behind the weapon. The rocket wobbled slightly as it left the tube, stabilizing fins deploying in flight. Flight time to target was less than 1 second. The shaped charge warhead struck the King Tiger's turret front, slightly left of the main gun. The explosion was sharp and loud, a metallic crack that echoed across the frozen fields. Smoke obscured the target for 3 seconds. When it cleared, the King Tiger was still moving forward. The turret was rotating. The long 71 caliber 8.8 centimeter gun was traversing toward Brookins' position. He had just told the tank exactly where he was. What Brookins didn't know, what most American infantrymen in December 1944 didn't know, was that the weapon he was holding represented the culmination of one of the most desperate and improvised weapons development programs in American military history. The bazooka had been conceived, designed, tested, and rushed into mass production in less than 30 days during the summer of 1942. It had been built by a team of scientists and engineers who were told that the laws of physics made their project impossible, that the weapon they were trying to create couldn't work, and that even if it did work, American industry couldn't manufacture it fast enough to matter. They built it anyway. They proved it worked. And by December 1944, American factories had produced over 470,000 bazookas and shipped them to every combat theater where American forces were fighting. The Germans had captured thousands of them, studied them extensively, built their own improved versions, and still fundamentally misunderstood why the weapon worked and what made it so effective. The story of how that happened begins not in the Ardennes forest in 1944, but in a research laboratory in Washington, D.C. in 1942, with a physicist who had an idea that everyone told him was ridiculous. The problem with destroying tanks wasn't new. It had been killing infantrymen since tanks first appeared on World War I battlefields in 1916. Armor was nearly invulnerable to rifle fire and machine gun fire. Artillery could destroy tanks, but artillery wasn't always available and couldn't respond quickly to sudden threats. Infantry needed a man-portable weapon that could penetrate heavy armor, but physics made that extremely difficult. A conventional high-explosive shell relied on blast effect. The explosive detonated and created a shockwave that could damage equipment and kill personnel, but blast effect alone couldn't penetrate thick steel armor. The shockwave dissipated too quickly. Against hardened steel plate, conventional explosives were essentially useless unless you used enormous amounts of explosive, which made the weapon too heavy for infantry to carry. Armor-piercing shells worked differently. They used kinetic energy, a solid metal projectile fired at extremely high velocity. The projectile's mass and speed allowed it to punch through armor plate. But achieving the necessary velocity required large guns with long barrels and powerful propellant charges. You couldn't make a man-portable weapon that generated enough velocity to defeat tank armor with kinetic energy projectiles. By 1940, both problems seemed insurmountable. Infantry anti-tank weapons were limited to relatively ineffective rifles, firing small, armor-piercing bullets that could barely penetrate light tank armor. Heavier weapons required wheeled carriages and gun crews. Nothing existed that a single soldier could carry and use effectively against medium or heavy tanks. Then, in 1938, a Swiss inventor named Henry Mohaupt developed something called a shaped charge. The concept wasn't entirely new. Scientists had known since the 1880s that if you hollowed out one side of an explosive charge and lined the hollow with metal, the explosion would focus into a jet of superheated metal and gas, traveling at velocities exceeding 25,000 feet per second. But nobody had figured out how to weaponize the effect reliably. Mohaupt's breakthrough was discovering the correct geometry. The hollow needed to be cone-shaped with specific angles. The metal liner needed to be made from specific materials, usually copper. And critically, the warhead needed to detonate at a specific distance from the target, called the standoff distance. If the warhead detonated too close to the armor, the shaped charge jet didn't have enough distance to form properly. If it detonated too far away, the jet dispersed before reaching the target. When everything was calibrated correctly, the shaped charge jet could penetrate armor thickness far exceeding what conventional explosives or kinetic energy projectiles could achieve. A relatively small warhead, maybe 2 pounds of explosive, could penetrate 4 or 5 inches of hardened steel. The physics were counterintuitive. You weren't blasting through the armor. You weren't punching through it with a solid projectile. You were essentially drilling through it with a focused stream of molten metal traveling faster than a rifle bullet. The American military learned about shaped charges in 1941, when Mohaupt demonstrated his designs for Army ordnance. The demonstrations were impressive. Small warheads penetrating thick armor plate consistently, but turning the concept into a practical weapon posed enormous challenges. You needed a delivery system that could get the warhead to the target, detonate it at exactly the right standoff distance, and do this reliably in combat conditions. The British were working on a similar weapon they called the PIAT, Projector Infantry Anti-Tank. It used a powerful spring mechanism to launch a shaped charge warhead, but the PIAT was heavy, cumbersome, required tremendous physical strength to cock, and had a maximum effective range of about 100 yards. The Soviets had developed anti-tank rifles and grenades with shaped charge warheads, but these were short-range weapons with limited effectiveness. In June 1942, the U.S. Army Ordnance Department received an urgent request from General George Marshall, the Army Chief of Staff. American forces were being deployed to the Pacific and would soon be deployed to North Africa. They needed an infantry anti-tank weapon immediately. something a soldier could carry, something that could destroy enemy tanks, something that could be manufactured quickly in large quantities. The request went to Colonel Leslie Skinner, an ordnance officer who had been experimenting with rocket-propelled weapons. Skinner had been working with a civilian physicist named Edward Oul at the Aberdeen Proving Ground in Maryland. Together, they had been testing small rockets as a way to deliver shaped charge warheads. The concept seemed absurd to most military engineers. Rockets were notoriously inaccurate. They had no rifling to stabilize them in flight like artillery shells. They wobbled and veered unpredictably. Using a rocket to deliver a precision weapon, like a shaped charge, which required hitting the target at a specific angle and distance, seemed like trying to perform surgery with a sledgehammer. But Skinner and Ewell believed they could solve the accuracy problem with proper fin stabilization. And rockets had one enormous advantage over gun-launched projectiles. They generated no recoil. A soldier could fire a rocket weapon from his shoulder without being knocked down by the recoil force. That meant the launching tube could be light, weight, simple, essentially just a metal pipe. In late June 1942, Oul was working in his laboratory at Aberdeen when he had the idea that would become the bazooka. He realized that if you made the launching tube exactly the same diameter as the rocket motor, you could use the tube as a guide to aim the rocket. The tube would keep the rocket stable during the critical first few feet of flight when the rocket motor was accelerating the projectile, but before the stabilizing fins had deployed fully. The tube could be simple steel pipe, open at both ends so the rocket motor exhaust could vent out the back, a trigger mechanism to fire the rocket motor's electric igniter, a simple sight for aiming, nothing complicated, nothing that required precision, machining, or complex manufacturing. UHL grabbed a piece of steel electrical conduit from a supply closet, cut it to about 4 feet in length, welded a simple grip and trigger assembly to it, and mounted a basic sight rail on top. He attached a rocket to test the concept. The whole assembly looked like something a plumber might use to clear a drain. It was ugly, crude, completely improvised. He took it to the firing range that afternoon and launched a rocket at a target 30 yards away. The rocket flew straight. The shaped charge warhead detonated on impact. UHL walked back to Colonel Skinner's office and said he thought he had something that might work. Preparing and narrating this story took us a lot of time. So, if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Over the next 2 weeks, Oul and Skinner refined the design. They tested different tube lengths and determined that 54 inches provided the best balance between accuracy and portability. They developed a shoulder stock to help soldiers aim the weapon. They added a simple electrical firing circuit with a trigger, battery, and wire leads to the rocket. The rockets themselves were developed in parallel by engineers working on shaped charge technology. The warhead was a steel cone filled with Composition B explosive, with a copper liner that would form the penetrating jet upon detonation. Behind the warhead was a small rocket motor using a solid propellant that burned for approximately half a second, accelerating the rocket to about 260 feet per second, stabilizing fins folded against the rocket body and deployed after launch. The complete weapon system consisted of 2 pieces, the launching tube and the rockets. A soldier could carry the tube slung over his shoulder and carry rockets in a backpack or supply bag. The weapon required a 2-man crew, a gunner who aimed and fired, and a loader who inserted rockets into the rear of the tube and connected the electrical firing wires. By mid-July 1942, Ewell and Skinner had a working prototype. They demonstrated it for Army Ordnance officials at Aberdeen Proving Ground. The test was scheduled as a preliminary evaluation, the first step in what everyone expected to be a lengthy development process involving engineering studies, safety testing, reliability trials, and then eventually, perhaps in late 1943 or 1944, a decision about whether to proceed with production. The test took place on a hot afternoon in mid-July. The target was a captured German tank sitting at a range of 50 yards. UHL loaded a rocket into the tube. Skinner aimed using the simple sight rail, He squeezed the trigger. The rocket motor ignited with a sharp crack and a burst of flame from the rear of the tube. The rocket flew straight to the target, and the shaped charge warhead penetrated the German tank's armor, punching a clean hole through 3 inches of steel plate. The ordnance officials stood there for a moment, looking at the hole in the tank. Then they asked Skinner to fire again. He fired 3 more rockets. All 3 hit the target. All 3 penetrated. The officials conferred briefly and then told Skinner they wanted 5,000 weapons manufactured immediately for field testing in North Africa. Delivery date, September 1st, 1942, 6 weeks away. Skinner explained that the weapon hadn't undergone any engineering evaluation, any safety testing, any durability trials, any manufacturing feasibility studies. None of the normal development steps had been completed. The ordnance officials said that none of that mattered. American infantry would be landing in North Africa in November. They needed anti-tank weapons. This weapon worked. Start production immediately. The official designation was Launcher Rocket Anti-Tank M1. But everyone who saw it immediately noticed that it looked like the musical instrument comedian Bob Burns played on his radio show. Burns played a homemade trombone-like instrument made from stovepipe and other scrap metal. He called it a bazooka. The name stuck. Within days, everyone was calling the new weapon a bazooka. Manufacturing 5,000 bazookas in 6 weeks should have been impossible. The weapon had never been mass-produced. No factories had tooling set up. No supply chains existed for the components. The shaped charge warheads required precision manufacturing to achieve the correct cone geometry and copper liner specifications. The rocket motors needed carefully formulated solid propellant that burned at consistent rates. The launching tubes needed to be straight and smooth to guide the rockets accurately. General Electric was given the contract to manufacture the launching tubes. They set up production lines at their Bridgeport, Connecticut facility. The tubes were made from seamless steel pipe, cut to 54 inches, with a wooden shoulder stock bolted to the bottom and a simple wire sight mounted on top. The electrical firing circuit consisted of a magneto-generator, a trigger switch, and 2 wire leads that connected to contacts on the rocket. Workers assembled these components by hand. The rocket warheads were manufactured by several contractors, including the Edward G. Budd Manufacturing Company in Philadelphia. Each warhead required precise machining. The steel cone had to be manufactured to exact dimensions. The copper liner had to be formed into the correct shape and thickness. The explosive filling had to be loaded carefully to avoid air gaps that would degrade performance. Quality control was critical. A warhead with incorrect geometry wouldn't penetrate effectively. The rocket motors were manufactured by firms with experience in pyrotechnic manufacturing. The solid propellant was a carefully formulated mixture that had to burn at a controlled rate to provide consistent acceleration. The propellant was cast into cylindrical grains and loaded into steel motor casings. Electric igniters were installed in each motor, connected to external terminals that the loader would attach to the firing wires. By September 1st, 1942, American factories had produced 5,000 M1 bazookas and 60,000 rockets. The weapons were crated and shipped to units training for Operation Torch, the invasion of North Africa. Nobody knew if they would actually work in combat. The testing had been minimal. The weapon was completely unproven. But American infantrymen were going to land on hostile beaches in November, and they needed something that could stop enemy tanks. The bazooka saw its first combat use on November 8, 1942, during the landings in North Africa. American forces came ashore at multiple locations along the coast of Morocco and Algeria. French colonial forces, nominally allied with Vichy France, resisted the landings with limited armored vehicles and defensive positions. The bazookas were distributed to infantry companies, typically 2 to 4 weapons per company. Most soldiers had never seen the weapon before. Training consisted of a brief demonstration and a few practice shots if ammunition was available. Many units landed with bazookas still in their shipping crates and had to figure out how to use them by reading the instruction manuals on the beach. The first confirmed bazooka kill occurred near Safi, Morocco, on November 8th. A French Renault tank was approaching American positions when a bazooka team engaged it at approximately 80 yards. The rocket struck the tank's side armor and penetrated. The crew abandoned the vehicle. The American soldiers who fired the shot reported being stunned that the weapon actually worked. They had expected the rocket to bounce off harmlessly. Over the following weeks, bazookas proved effective against the relatively light armor of French colonial forces. The weapon was less effective against German tanks that American forces began encountering in Tunisia in early 1943. German Panzer III and Panzer IV tanks had thicker armor than French vehicles. Bazooka crews learned they needed to aim for vulnerable points, turret rings, engine compartments, tracks, vision ports. The Germans captured their first bazookas in Tunisia in early 1943. German intelligence officers examined the weapons extensively. They were initially dismissive. The launching tube was crude, just a steel pipe with a grip and trigger. The sight was primitive. The entire weapon looked improvised, like something designed in a hurry by people who didn't know what they were doing. But when German engineers tested captured bazookas and rockets, they discovered the weapon worked remarkably well. The shaped charge warheads could penetrate 100 millimeters of armor at optimal angles. The rockets were reasonably accurate out to 150 yards. The weapon was simple enough that minimally trained soldiers could use it effectively. And most importantly, the weapon had no recoil, which meant it could be fired from confined spaces or from positions where a conventional anti-tank gun couldn't be employed. German weapons designers immediately began working on their own version. They called it the Panzerschreck, meaning tank terror or armor terror. The German version was larger than the American bazooka, with an 88mm caliber rocket compared to the bazooka's 60mm. The warhead was heavier and could penetrate thicker armor. The Germans also added a blast shield to protect the gunner's face from the rocket motor exhaust. By late 1943, German forces were using Panzerschrecks extensively on the Eastern Front and in Italy. But the Germans made one critical mistake in their analysis of the bazooka. They assumed the weapon's effectiveness came primarily from the larger caliber and more powerful warhead they had developed. They thought the American bazooka was underpowered and ineffective, a crude stopgap weapon that Americans used only because they had nothing better. What the Germans failed to understand was that the bazooka's real advantage wasn't the size of its warhead. The advantage was that American industry could manufacture bazookas and rockets far faster than German industry could manufacture Panzerschrecks. By the end of 1943, American factories were producing 20,000 bazookas per month and over 1 million rockets per month. German production of Panzerschrecks never exceeded 3,000 per month. The production disparity meant that American infantry units had bazookas available in abundance. Every rifle company had multiple bazooka teams. Ammunition was plentiful. Soldiers could fire multiple rockets at a target if the first shot missed. They could engage targets at longer ranges where the probability of a hit was lower because they had enough ammunition to accept the waste. German forces, meanwhile, had to carefully ration Panzerschreck ammunition. Units typically received limited rocket supplies and were instructed to fire only when certain of a hit. This made the more Folge German weapon less effective in practice because crews couldn't afford to miss. The psychological pressure of having only 1 or 2 shots available often caused gunners to hesitate or rush their aim. American soldiers also developed tactics that maximized the bazooka's effectiveness. They learned to work in teams, with multiple bazooka crews engaging the same target from different angles. They learned to aim for specific vulnerable points on German tanks. They learned that firing at the side or rear armor was far more effective than frontal shots. They learned that tracks and suspension could be disabled even when the warhead didn't penetrate the main armor. By mid-1944, the bazooka had been improved several times. The M9 version, introduced in early 1944, had a larger 60mm warhead with improved penetration. The M9A1, which entered production in late 1944, broke down into 2 sections for easier transport. Both versions were more effective than the original M1, but the basic design remained unchanged. A simple tube, a shaped charge rocket, a shoulder-fired system requiring minimal training. The Germans continued to believe their Panzerschreck was superior. In terms of raw penetration capability, they were correct. The German 88mm warhead could penetrate 160 millimeters of armor under ideal conditions. The American 60mm warhead could penetrate approximately 110 millimeters. But combat isn't conducted under ideal conditions. Combat is messy, chaotic, unpredictable. The weapon that's available in quantity and can be used by minimally trained soldiers often matters more than the weapon with theoretically superior performance. Which brings us back to Private First Class Richard Brookins in a frozen ditch near Krinkelt, Belgium, on December 18th, 1944, having just fired a rocket at a King Tiger tank that weighed 68 tons and had armor up to 180 millimeters thick in places. His first shot had struck the turret front and failed to penetrate. The King Tiger was still advancing. The turret was traversing toward his position. Brookins reloaded. His loader, Private Eugene Wilson, slid the second rocket into the rear of the launching tube and connected the firing wires while lying flat in the mud. The King Tiger's machine gun began firing, tracers snapping overhead. Brookins could hear the main gun traversing, the electric motors whining as the massive turret rotated. He didn't have time to aim carefully. He pointed the bazooka at the tank's hull, low, hoping to hit the drive sprocket or the tracks. He fired. The rocket left the tube, stabilized in flight, and struck the King Tiger's left track approximately where the track wrapped around the drive sprocket at the front of the hull. The explosion severed the track. The heavy steel links fell away from the road wheels. The King Tiger lurched to the left as the broken track jammed in the sprocket mechanism. The tank stopped moving forward. The turret continued traversing, but now the entire vehicle was stationary, immobilized. German infantry who had been following the tank immediately took cover. Without the tank's protection, they were exposed to American small arms fire. Brookins and Wilson abandoned their position and fell back to the next defensive line where the rest of their company was dug in. Behind them, the immobilized King Tiger fired several rounds at suspected American positions, but without infantry support and without mobility, the tank was vulnerable. Within 20 minutes, an American tank destroyer had worked its way into a flanking position and destroyed the King Tiger with 2 shots to its side armor. Brookins learned later that morning that his unit had knocked out or immobilized 7 German tanks during the initial hours of the Battle of the Bulge using bazookas. Not all were King Tigers. Most were Panzer IVs and Panthers. But the tactic was the same. Aim for tracks, aim for vulnerable points, disable mobility, even if you can't achieve a catastrophic kill. The Battle of the Bulge, Germany's last major offensive in the West, lasted from December 16, 1944 to January 25, 1945. German forces committed over 400,000 men and over 1,000 tanks to the offensive. The attack achieved initial surprise and made significant gains in the first few days, but American defensive positions in towns like Bastogne and along the Elsenborn Ridge held long enough for reinforcements to arrive. Bazookas played a significant role in the defense, particularly in the early days when American forces were outnumbered and surrounded. Infantry armed with bazookas could engage German armor in close terrain, where the Americans' numerical disadvantage in tanks mattered less. In towns and villages, bazooka teams operated from buildings and rubble, engaging German tanks at ranges where the bazooka's limited accuracy was less of a handicap. The effectiveness wasn't measured in catastrophic kills. Most bazooka hits on heavy German tanks like Panthers and King Tigers didn't penetrate the frontal armor, but they damaged tracks, destroyed vision ports, disabled weapon systems, forced crews to button up and lose situational awareness, and most importantly, slowed the German advance. A disabled tank blocking a narrow village street could stop an entire column. A tank with damaged tracks became a stationary pillbox, dangerous but immobile. German tank crews who knew American infantry had bazookas became more cautious, moved more slowly, stayed buttoned up longer, which degraded their combat effectiveness even when no bazookas were actually present. German after-action reports from the Battle of the Bulge frequently mentioned American anti-tank weapons, but they often couldn't distinguish between bazooka hits, tank destroyer fire, and artillery. All they knew was that tanks were being damaged and destroyed at higher rates than expected. The assumption was that Americans had brought up more anti-tank guns and tank destroyers than intelligence had predicted. Few German commanders realized that much of the anti-tank defense was being provided by infantrymen with shoulder-fired weapons that German doctrine still considered largely ineffective against heavy armor. The psychological impact mattered as much as the physical damage. Tank crews operating in terrain where bazookas might be present had to constantly scan for threats, worry about ambushes, move more cautiously. This slowed operations and degraded offensive momentum. By late January 1945, the German offensive had been completely defeated. American and British forces had pushed the German lines back to their starting positions. The Battle of the Bulge cost Germany irreplaceable losses in men and equipment, over 100,000 German casualties, over 800 tanks destroyed or abandoned, fuel and ammunition expenditures that Germany could not replace. American forces also suffered heavy casualties, approximately 80,000 men killed, wounded or captured. But American production capacity meant those losses could be replaced. Tanks, vehicles, weapons, ammunition, all could be manufactured and shipped to Europe in quantities Germany couldn't match. The bazooka exemplified this production advantage. By the end of the war in May 1945, American factories had produced over 476,000 bazookas of all variants. Rocket production exceeded 18 million rounds. These numbers dwarfed German Panzerschreck production, which peaked at approximately 314,000 launches total for the entire war. The Germans had designed a technically superior weapon, but couldn't manufacture it in sufficient quantities. The Americans had designed a simpler weapon that was good enough and could be mass-produced. In industrial warfare, good enough in large quantities often beats superior in small quantities. After the war, American intelligence officers interrogated German tank commanders and asked about their experiences fighting against bazookas. The responses were revealing. Most German tankers said they considered bazookas dangerous, but not as threatening as American tank destroyers or medium tanks. They had learned that frontal armor on Panthers and King Tigers could usually stop bazooka rockets. They had learned to keep infantry support close to prevent bazooka teams from getting flanking shots, but they also admitted that the constant threat of bazookas influenced their tactical decisions. They avoided confined terrain where possible. They moved faster through towns to minimize exposure. They kept infantry closer, which reduced the infantry's effectiveness as independent units. The bazooka shaped German tactics, even when it wasn't achieving kills. The American military conducted its own analysis of bazooka effectiveness after the war. Statistical studies examined engagement reports from all theaters. The data showed that bazookas accounted for approximately 7% of total German tank losses in the European theater. 7% doesn't sound impressive until you realize that bazookas were shoulder-fired weapons used by infantry, while the other 93% of tank kills required dedicated anti-tank guns, tank destroyers, medium tanks, heavy tanks, or artillery. For a weapon that cost approximately $25 to manufacture, required minimal training to use, and could be carried by a single soldier, 7% of total enemy armor kills represented extraordinary effectiveness. The bazooka gave infantry genuine anti-armor capability for the first time in military history. Prior to the bazooka, infantrymen could harass tanks, but couldn't reliably stop them. The bazooka changed that calculation. WWII, the physicist who had grabbed a piece of electrical conduit from a supply closet and turned it into the bazooka, received relatively little public recognition during or immediately after the war. His name appeared in some technical publications and military reports, but he never became famous. He was awarded the Legion of Merit for his contribution to weapons development, a decoration that few people outside the military knew about. After the war, WWII returned to civilian life. He worked as an engineer in private industry, eventually becoming a vice president at Fairchild Engine and Airplane Corporation. He held over 20 patents for various inventions, though none achieved the impact of the bazooka. He rarely spoke publicly about his role in developing the weapon. In interviews later in his life, WWII said he never expected the bazooka to become as significant as it did. He thought he was building a stopgap weapon that would be used for a few months until something better could be developed. He was surprised when the basic design remained in service throughout the war with only minor modifications. He was even more surprised when post-war analysis showed how many tank kills the weapon had achieved. WWII died in 1997 at age 89. His obituary in the New York Times mentioned his role in developing the bazooka, describing it as a weapon that gave American infantrymen a fighting chance against enemy armor. The obituary didn't mention that WWII had built the prototype in one afternoon using scrap materials, or that the entire development process from concept to mass production had taken less than 60 days. Colonel Leslie Skinner, who had worked with WWII to develop and test the bazooka, also received limited public recognition. He continued his career in Army Ordnance after the war, eventually retiring as a colonel. He was awarded the Distinguished Service Medal for his contributions to weapons development during World War II. Like WWII, Skinner rarely discussed his role in creating the bazooka publicly. The weapon itself remained in American service long after World War II ended. During the Korean War from 1950 to 1953, American forces used improved versions of the bazooka against North Korean and Chinese armor. The newer M20 Super Bazooka had an 89mm caliber and significantly improved penetration, but the basic operating principle remained unchanged from WWII's original design. The bazooka influenced anti-tank weapon development worldwide. The Soviet Union developed the RPG series of rocket-propelled grenades, which used similar-shaped charge warheads and rocket propulsion. These weapons became ubiquitous in conflicts throughout the Cold War and remain in widespread use today. Nearly every military force in the world now fields some type of shoulder-fired anti-tank weapon descended conceptually from the bazooka. The shaped charge technology that made the bazooka effective also influenced the development of anti-tank guided missiles, artillery shells with shaped charge warheads, and specialized anti-armor weapons for helicopters and aircraft. The principle of using a focused jet of superheated metal to defeat armor became fundamental to modern anti-armor warfare. But the bazooka's most important legacy wasn't technological. It was demonstrating that relatively simple weapons, if produced in sufficient quantity and distributed widely to combat troops, could significantly impact the battlefield, even against technically superior enemy equipment. The bazooka wasn't the best anti-tank weapon of World War II. It wasn't the most powerful or the most accurate, but it was good enough, and American industry could produce it faster than any alternative. Private First Class Richard Brookins survived the Battle of the Bulge. He continued fighting with the 2nd Infantry Division through the final months of the war, participating in the Allied advance into Germany. He was present when American forces reached the Elbe River in April 1945 and made contact with Soviet forces advancing from the east. Brookins was discharged from the Army in November 1945. He returned to Ohio, married his girlfriend from before the war, and took over his father's hardware store. He ran the business for 40 years until retiring in 1985. He rarely talked about the war. When customers noticed he walked with a slight limp from frostbite damage sustained during the bulge, he would change the subject. In 1994, on the 50th anniversary of the Battle of the Bulge, a local newspaper interviewed Brookins about his experiences. He told the story of firing at the King Tiger tank with a bazooka near Krinkelt. The reporter asked if he had been scared. Brookins said he had been too busy to be scared, too focused on loading and aiming and firing to think about what might happen if he missed. The reporter asked if Brookins had ever thought his bazooka shot could stop a King Tiger. Brookins said he knew it probably wouldn't penetrate the armor, but he thought he might be able to damage something important, break a track or disable a weapon. He said most of the soldiers he knew who used bazookas understood the weapon's limitations. They weren't expecting miracle kills. They were just trying to slow the tanks down, give American anti-tank guns and tank destroyers time to get into position, buy time for their units to establish defensive positions. Sometimes, Brookins said, that was enough. Sometimes slowing the enemy down for 5 minutes made the difference between holding a position and being overrun. The bazooka gave infantry that capability. Before the bazooka, infantry facing tanks had 2 options: retreat or die. With the bazooka, they had a third option: fight. Brookins died in 2001 at age 78. He was buried with military honors in his hometown cemetery. Among his possessions, his family found a small wooden plaque he had kept in a desk drawer. The plaque had been made by someone in his unit during the war, a piece of wood with burned lettering that read Bazooka Team, 2nd Battalion, 23rd Infantry, Krinkelt, December 1944. The bazookas themselves mostly disappeared from public view after the war. Thousands were stored in military depots. Many were scrapped when newer weapons entered service. Some ended up in museums. A few remained in private collections. The weapon that had been rushed from concept to production in 30 days, manufactured by the hundreds of thousands and given to American infantrymen who desperately needed something to stop enemy tanks, became a historical curiosity. But the soldiers who carried bazookas remembered. They remembered the weight of the launching tube on their shoulders. They remembered the electrical hum of the magneto when they squeezed the trigger. They remembered the sharp crack of the rocket motor igniting and the blast of heat from the exhaust. They remembered aiming at tanks that seemed invulnerable and pulling the trigger anyway because that was the job. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.